Assalamualaikum boys, welcome to your mathematics class. We will solve the last three parts of exercise 1.4 in this lecture. Let me remind you what the radical equations were. Radical equations and equations involving expression under the radical sign, that is the under root sign, is called radical equation. We were given with three types of radical equation. The first type was done in the first four questions of the exercise 1.4. The second type was done in the question 5 to 8 of the exercise 1.4. Now we are going to deal with the third type of our radical equations. In this type, you can see that x square plus px is common in both the radical signs. So we have to take it as a common digit and we will suppose it as equal to some other variable. Our question is, solve the following equations. We have to solve the ninth part, which is under root x square plus x plus 1 minus under root x square plus x minus 1 equals to 1. As I told you before, in these questions, we will be having some common digits inside the root. In part 9, we can see that x square plus x is common to both the roots. We can see x square plus x under both the roots. So we will suppose it first. We will say that x square plus x equals to y. Now we will replace this digit with y. Putting y in place of x square plus x, we will get under root y plus 1 minus under root y minus 1 equals to 1. I haven't written x square plus x, I have replaced it with y. Plus 1 remains the same, plus and under root remains the same. Again x square plus x has been replaced with y and minus 1 remains the same. Now the next part is same, which is squaring both sides. After taking the square of the right and left side, we will get the square of under root y plus 1 minus under root y minus 1 and the square of 1. Talking about the left hand side, under root y plus 1 indicates a and under root y minus 1 indicates b. So we can open this formula using a minus b whole square. The formula of perfect square, negative perfect square identity will be applied. So a is under root y plus 1 and b is under root y minus 1. So a minus b whole square is equals to a square plus b square minus 2ab. So I will write a square under root y plus 1 whole square plus b square, which is y minus 1 whole square, minus 2ab. ab can be written inside one radical, and taking the square of 1 is 1. Roots will get cancelled with the square, so y plus 1 plus y minus 1 will come outside the bracket root, and minus 2 under root y plus 1 y minus 1 will get multiplied with each other. We will get y square minus 1y plus 1y minus 1. Now we can see that plus 1y and minus 1y, same digits having the opposite signs, can be cancelled with each other. So and again minus 1 and plus 1 can also be get cancelled. So y plus y is 2y minus 2 under root y square and minus 1 remains equals to 1. Taking this 2y to the other side of the equation, we will get minus 2 under root y square minus 1 equals to 1 minus 2. This is the last step from the previous slide. Now again, as we are having still a radical sign here, so we will take the square again squaring both sides. We will get the square of minus 2 under root y square minus 1 and the square of 1 minus 2y. Minus squaring minus is always a positive sign. 2 2's are 4 and this root will get cancelled with square, so it will be y square minus 1. And to the right side of the equation, 1 minus 2y, we will apply the formula of a minus b whole square, where a is 1 and b is 2y. So 1 square minus 4y plus 4y square. Multiplying y square minus 1 with 4, we will get 4y square minus 4 equals to 1 minus 4y plus 4y square. Taking all the digits to one side of the equation, we will get 4y square minus 4 minus 1 plus 4y minus 4y equals to 0. So plus 4y and minus 4y will get cancelled with each other. The only thing remain is 4y and minus 4 minus 1 is minus 5. We supposed y as x square plus x. So putting y is equals to x square plus x in the above equation, we will replace y with x square plus x. It will become 4x square plus 4x minus 5. The last step from the previous slide is 4x squared plus 4x minus 5 equals to 0. If we want to break the midterm here, then 4 into 5 is 20. We have to break 4 in such a way to get 20 after multiplication, but there is no way possible to get it. So we will apply the quadratic formula. Applying the quadratic formula, the coefficient with x square is a, the coefficient with x is b, and the coefficient or the constant term is c. Putting the values a and b and c in the quadratic formula, we will get minus into 4 plus minus under root 4 square minus 4 into 4 into minus 5 over 2 into 4. Opening all the brackets, we will get minus 4 plus minus under root 16 plus 80 by 8. 16 plus 80 is 96. If you write under root 96 in the calculator, you will get the answer 4 under root 6. Now taking common from minus 4 and 4 under root 6, we will get 4 into minus 1 plus minus under root 6 over 8. Cancelling 4 with 8, we will get our answer minus 1 plus minus under root 6 by 2. We won't be able to put this in the given equation to search for the extraneous root. So in this case, this is our answer. We will solve another similar example in this question. Here again, we are having some common digits inside the radical sign. These common digits are x squared plus 3x, and the same x squared plus 3x is present in the second radical. So again, this is the third form of radical equations. In the third form, what we first do, we first suppose the common digits as equals to y, and then we replace all these digits, that is x squared plus 3x, with y. So writing the equation again, we will have y plus 8 plus under root y plus 2 equals to 3. The next step is to take the square on both the sides. We will take the square of the left side and the square of the right side. Taking the square of the left side, we will get under root y plus 8 plus under root y plus 2 whole square, which means our under root a plus 8 is indicating a and under root y plus 2 is indicating b. So whenever to open the formula, we will open the formula of a plus b whole square. In place of a, we will write y plus 8 under root, and in place of b, we will write under root y plus 2. So opening the formula, we will get a square plus b square plus 2ab equals to the square of 3 is 9. Cancelling the root with the square sign, we will get y plus 8 plus y plus 2 under root y square plus 2y plus 8y plus 16. This side we get after multiplication of these two brackets. 2y and 8y are having the same variable with them, so they are common same digits. 2y plus 8y will become 10y. Y plus y is 2y and 8 plus 2 is 10. Taking 2y and 10 to the other side of the equation, the signs will change, minus 2y and minus 10y. Subtracting them, we will get minus 2y minus 1. I will take minus sign common from this, so it will become 2y plus 1. The last step was 2 under root y square plus 10y plus 16 equals to minus bracket 2y plus 1, which means we are having again a radical sign, so we have to take the square again. Taking square on both sides, as we are going to take the square of 2 separately and the square of under root y square plus 10y plus 16 separately, same goes to the right side. We will take the square of minus and then we will open the 2y plus 1 bracket with the formula. The square of 2 is 4 and the expression under the radical sign will remain the same because the root has got cancelled with the square. So y square plus 10y plus 16 equals to minus minus is plus. So no signs will get changed. 2y plus 1, here 2y indicates a and 1 indicates b. So a plus b whole square is equals to a square plus 2ab plus b square. Opening the brackets and multiplying it with 4, we will get 4y square plus 40y plus 64 equals to 4y square plus 4y plus 1. Taking all the digits to the left side of the equation, all the signs will get changed. Plus 4y to minus, and plus to minus again. Plus 4y square and minus 4y square, same digits having this opposite signs, they will get cancelled and the answer will be 0. Plus 40y minus 4y will become plus 36y, plus 64 and minus 1 will become plus 63. In this 36 and 63 we can take some common number which is 9. So 9 into 4y plus 7 equals to 0. Taking 9 to the right side, it will divide with 0 and the answer would be 4y plus 7 equals to 0. Now we have to replace the y with the digits or the expression that we supposed earlier. So putting y is equals to x square plus 3x in the above equation, we will get 4 brackets x square plus 3x plus 7 equals to 0. Opening the brackets and multiplying it by 4, we will get 4x square plus 12x plus 7 equals to 0. 4 into 7 is 28. We cannot break the midterm with the two digits that multiply to get 28 and add or subtract to get 12. So again we will apply the quadratic formula. The coefficient with x square is a, which is 4. The coefficient with x is b, which is 12. And the constant digit is c, which is 7. Applying it in the formula, we will get minus into 12 plus minus under root 12 square minus 4 into 4 into 7 over 2 into 4. Taking the square and opening the brackets, we will get minus 12 plus minus under root 32 by 8. If you will write under root 32 in the calculator, you will get the answer 4 under root 2. We can take common 4 and 12, both can be divided by the same number, that is 4. So 4 3 times 12. So we will write minus 3 inside the bracket, plus minus will remain the same as 4 is outside the bracket, so only under root 2 will remain inside the bracket. 4 and 8 will get cancelled with each other. So our answer is minus 3 plus minus under root 2 by 2. Again the answer is in this form, so we will simply write it in the solution set. Coming to question number 11. Question number 11 says under root x square plus 3x plus 9 plus under root x square plus 3x plus 4 is equals to 5. What are the common digits inside the radical sign? The common digits are x square plus 3x. So first of all, we will suppose x square plus 3x as equals to some other variable. I say that x square plus 3x is equals to y. We will replace x square plus 3x as y in the given equation. The equation will become under root y plus 9 plus under root y plus 4 equals to 5. The next step is same. We will take the square on both the sides. After taking the square, under root y plus 9 will behave as a and under root y plus 4 will behave as b. So a plus b whole square is equals to a square plus b square plus 2ab equals to the square of 5 is 25. Cancelling the square with the roots and multiplying y plus 9 with y plus 4, we will get y plus 9 plus y plus 4 plus 2 under root y square plus 4y plus 9y plus 36 equals to 25. Plus 9y and plus 4y, adding them will become 13y, y plus y will become 2y and 9 plus 4 is 13. Taking 2y and plus 13 to the other side of the equation, it will become 25 minus 2y minus 13. On the right side, we will get minus 2y plus 12. We can take minus 2 as the common digit, y plus minus 6 will remain inside the bracket as minus has been taken as a common sign, so plus has been changed to minus. Again only a single radical sign, so taking square again, squaring both the sides, we will get the square of 2, which is 4, and the root will get cancelled with the square. So the expression under the radical sign will remain the same. Taking the square of minus 2 is also plus 4, because minus minus plus and 2 times 4. Y minus 6, we will open it using the formula of a minus b whole square. This is a square minus 2ab plus b square. Now multiplying the brackets, we will get 4y square plus 52y plus 144 equals to 4y square minus 48y plus 144. Taking all the digits to the left side of the equation, the right side will become equals to 0. Now you can see 4y square and minus 4y square, the same digits with opposite signs, so they will get cancelled with each other. The answer will be 0. Plus 144 and minus 144 will also get cancelled with each other, and the remainder will be 0. So only the thing remains is plus 52y plus 48y. So the answer would be 100y equals to 0. We can divide that 100 with 0. Y is equals to 0 is the answer, but that is not the answer, as the question was in terms of x, so we have to find the value of x. Putting the values of y in the given equation, y we supposed as x square plus 3x equals to y, so now we will replace y with the x square plus 3x. The equation will become x square plus 3x equals to 0. Taking x as the common digit, we will get x plus 3 inside the bracket. Splitting these two, we will get x equals to 0 and x plus 3 equals to 0. The answer of x will become 0 and minus 3. Now you can see these are the simple answers, so we can check for the extraneous roots here. Putting the values one by one in the given equation to check for extraneous roots. Putting x is equals to 0, our equation was x square plus 3x plus 9 and x square plus 3x plus 4 equals to 5. Multiplying the digits with 0, the answer will be 0, so we will have 9 inside first root plus 4 inside the other root equals to 5. The root of 9 is 3 and the root of 4 is 2, so the answer will be 5 equals to 5, which means our answer 0 is the actual answer of x. Putting x equals to 3, again applying the same formula. The square of minus sign is always a positive sign. 9 minus 9 will get cancelled, so only plus 9 will remain inside the root. Again 9 minus 9 will get cancelled and plus 4 will remain inside the root, so the solution is same. 3 plus 2 equals to 5 and 5 equals to 5, which mean both the answers are correct. So our solution set will be minus 3 and 0.